Hassan, dear students, today I am with another lecture of basic electronics. Uh, and I'm hopeful that you all are fine at your house with your families. Stay safe and stay at your home. This will be better for you and your families. Today we're going to discuss in the chapter of basic electronics, the next chapter, that is basically the new chapter. In this chapter, we are discussing about, as in my previous lecture, we discussed on the JFETs, that means junction field effect transistor. And today we are talking about its basic type, that is called N-channel J.F.E.T, N-channel junction field effect transistors. So we will go towards its introduction about N-channel J.F.E.T. N-channel junction field effect transistors introduction is here. It is a type of field effect transistor, as we showed as it is here. It has a junction between channel and gate. The flow of current is due to majority carrier electrons. Simple thing. The channel between the junction between channel and gate is called N-channel junction field effect transistors. What is its function? There are basically two functions always been, as I have discussed with you people in the chapter of transistors. There is only one working principle, that we have to exchange the terminals of battery according to the terminals. So, what is the function number one? When negative terminal of battery is connected with source, when negative terminal of battery is connected with this source, and positive terminal of battery with drain terminal of N channel. With positive, here you are watching that this is the positive terminal of the battery. The name of the battery is VDS. That is simply from these two terminals. So the drain is connected with the positive terminal of the battery VDS, and the negative terminal is connected with the source. And the gate is always means connected with another battery. There are two batteries. This battery is showing over here. VGS is showing that the negative terminal of the battery is connected to the gate, and the positive terminal is showing this position. So simply here we are watching the two gates. Gate and source terminals are as you are watching that this in this position. So when this position is here, then the negative terminal of battery on source repels the electrons. As in result, what will happen? The electrons will be repelled, and the positive terminal of the drain attracts the electrons, which causes to flow the electrons very easily through the channel. Electrons will flow very much easily. In this case, when negative terminal of battery is connected with source and drain is connected with the positive, the electrons will easily flow from source to drain, and we got the output from RD. RD means resistance of output, that is called RD. So we get output from this RD output. In the next, what will happen in the second stage? When negative terminal of battery is connected with gate, then negative terminal is connected with the gate, and positive terminal of battery with source of J.F.E.T, junction field effect transistors. Look at it, it's very much clear. Then gate and source junction will be reverse biased, and gate and source junction is right now in reverse bias condition, and this is in forward bias condition. As a result, the width of the channel will increase, and no electrons would flow through it. The very minimum ratio of the electrons would flow through it. This is a simple lecture. Here you have seen what I want to tell you, that in this condition, gate and source are reverse biased, while source and drain are forward biased. As a result, no current flow through it. No current will flow through it. And in this condition, what happens? In this condition, this happens that source and drain are reverse biased, and gate and source are forward biased. This section was forward biased and this section was reverse biased. As a result, it caused to flow the electrons very easily. When this section is reverse biased and this section gate and source, means that gate and source section terminals are both are reverse biased and drain and source are forward biased. No current will flow through it. It is very much similar to the electrons, to the transistors working principle. Two batteries at the same criteria. That's right over here. The two terminals are gate and source. Gate and source, as we discuss in transistors, only two functions. Two batteries will be connected to the FETs. Secondly, gate and source function must be forward biased. Number three, source and drain would be reverse biased. When both these conditions happen, then current will flow very easily. And if the terminals exchange their positions, then no current will flow through it. Now let us see the module structure of this. VGS, this is basically N channel FET because arrow is going inside. Gate, source and drain. Gate terminal is associated with resistance that is nominated as RG, gate resistance. This is drain resistance, and this is your second battery, that is voltage drain to source battery, and here is another battery that is voltage gate and source battery. This is the simple circuit structure. It was the physical structure or simply a circuit diagram. Characteristic curves. In this characteristic curves, as we know that this is the output voltages, we will calculate the output voltages through this drain resistance. And this is ID. ID is drain current, means output current. So we are here measuring the voltages and currents according to this through this resistance. Why we are measuring voltage and current? Because simple Ohm's law. Remember the Ohm's law. What Ohm's law states that? Ohm's law states that E is equal to I. I is equal to V by R, and R is equal to V over I. Simple. So what we have achieved here, that this is drain resistance. We have drain resistance over here. This drain resistance we mentioned RD. RD is equal to the output voltage, that is VDS, and the current, that is ID. When we will multiply this type of sword, we have the output resistance, total output resistance. And when we want to know the drain current, ID is equal to VDS divided by the RD. We have output current over here. Well, simply when we want to know voltage, total voltages, we will say VGS multiplied by the IG, input current multiplied by the RG. So these are the simple basic laws from Ohm's law, and when you will calculate these formulas, you will have complete shape. What happens is the current rapidly increases through -3 milliamperes in the gate to source output. In second stage, it steps up to -2, then -1, then 0. And when we will switch off at the saturation point, when you cut off these points and it becomes at the saturation point, this will decrease step by step down towards the zero level. Simply, this was your today's lecture of N-channel junction field effect transistors. Hopefully, you may understand this lecture, and if you found any kind of problem in this lecture, you may ask me on my Google Classroom or my WhatsApp number. Thank you so much, and hope you have understand this. As an assignment, you should write this topic on your assignment as an assignment and submit it on the Google Classroom. Thank you so much, boys. Allah Hafiz.